right, OBS is going. Welcome to Tryhackme at night number 2. Today we're gonna be doing the Tryhackme room hijack. Let's get signed in here. Let's see. Little captcha. There we go. All right. Go to hijack and do that. All right. All right. So once again, welcome to the Kryptas community live stream. We're going to be doing a Tryhackme tonight. The Tryhackme room in question is Hijack. This one recently came out. And let's get started. All right. I want to move this just back up to my second monitor here, and we're going to get started. We're going to start a new TMUX session, so we can type in TMUX new, TAC S for, specifying the name, and we'll just call it, I don't know, work. And good. Let's see. All right, it's a little finicky. It wants to jump down here, but that's all right. We'll create a few. Which call this one VPN. We'll call this one notes. Call this one nmap. We'll start there. All right, and then let's scroll back in just so that everyone can see nice and clearly. Make sure that I can see what I'm doing. Make sure I'm not showing you guys the wrong monitor. All right. So let's go into classes, Tryhackme. We'll open VPN, our VPN file. And from the looks of it, it looks like it's doing good here. Let's go back into that. Oh, we'll just do it here actually. Nano notes.text. And we'll do IP. We'll do ports. And maybe we'll do like reds. Okay. Go back, we'll look at our Tryhackme IP address. The machine that we are attacking is 72.25. 10.10.72.25. Alright, so let's get started with some nmap scans. Scroll this in, we'll go nmap, attack T5, and then we'll just do a basic top 1000 ports. We'll let that run. And then let's come back and let's start another one that's going to be scanning all 65,535 ports. That way we don't miss one. So just to go over it again, nmap tech T5 is the time, so how fast we want it to go. 5 is one of the higher ones. Tech P tech is hey, scan all ports, basically. Attack all 65,535, and this is the address we want to scan. All right, let's go back to that initial scan, and we can see, hey, 21's open, 22, 80, 111, and 2049. All right, so why don't we note this? We'll go back over to our notes page, and right there. Always a good time. Let's go back to doesn't want to copy and paste. Let's go back to here and we'll just do the integration then. All right. Tech T5 for time, Tech SC for safe scripts, Tech SV for version, Tech SS for SYN, or the halfway handshake, and then let's specify ports. So we got 21, 22, we got 80, we got 111, and we got 2049. And then the host 10, 10, 72, 25. We'll let that run. Let's see. All right. So we came back, it scanned all ports, and it found these 4 kind of higher level ports. We'll take note of these. And if we can't find anything on these, we'll come back and we'll check these. Just because these are higher level ports and they're unknown. But we could still enumerate them. So let's keep that in mind. Let's come over here and let's see if it'll play nice and let us copy and paste again. No, still doesn't like us. All right. Let's come over here. We'll grab this information, throw this into our notes if it'll let us. No. All right, we'll just start up Sublime Text then if it wants to be like that. Sublime Text. There we go. All right. And that was our notes from last time. Pseudo version and all that other stuff. New file. No, we don't want to save. And let's go with IP and ports. All right. Come back over here. We'll grab those. Awesome. And let's take a look at it. So we got FTP version 3.0.3. And for HTTP, we got Apache 2.4.18. Then it looks like RPC bind, some maybe an NFS share. Yeah, it looks like we can mount to it. So possibly a share that we can look into, and then FTP that we can try to gain access to as well. And then let's check out what's on that website here. So let's note these other 4 ports here. All right. Let's start with FTP. So let's FTP 72.25. We can check if it'll allow anonymous access. We just type in the user anonymous and then we leave password blank. And if FTP is set up or misconfigured, it would allow us to sign in, anonymously, allow us to access that share. But from the looks of it, login failed. All right, let's maybe just try something stupid. Let's do anonymous and then password as the password. Nope, still nothing. Let's come over here. We'll do maybe like admin. Yeah, all right. So we're going to need to find some credentials for FTP. So why don't we check out that NFS share? I believe with NFS it's show mount. Yeah, show mount, and then we can put in the IP address here. So show mount's going to say, hey, here's an exported list of all the mount points for this host. So on that host, they have a mount share folder that we can mount to. So let's mount to NFS 10.10.72.25. And let's mount it to our mount Hijack. And it's going to be mounting to... Actually, let me pull up my notes. I want to make sure I get that syntax right. Actually, mount share and then okay, 10.72.25 mount share and then where we want to mount it. THM Hijack. Hello. Am I become unresponsive? Yeah, that just died for me. Let's close that out. Let's create another one. All right. Tag TNFS 10.10. Go back 72.25. Mount share, and we want it to go to mount THM hijack. It keeps breaking. Why don't we just set up another? Let's go to mount, and we'll remove that THM. It'll allow us. We'll just make another directory, call it, we'll go in there. Might be broken, might be another share in there that might give us issues. Let's go to, we'll just make a directory called share, and then we'll cd into share, and then we'll make another directory called hijack. All right, now let's go back to where we were, and we'll mount txt nfs 10.10.72.25 mount share, and then we are going to mount it to mount share hijack. And let's see what that does for us. Let's see if it mounts. Looks like it did. We're gonna go to mount share hijack. And it says, hey, permission denied, which is kind of weird, right? Because we're root. We should be able to get into everything and anything that we want within our own machine, right? But how this is basically working is we are attaching to the share on that remote host, right? So technically, we don't have permission to view that share, but what we can do is let's go to that directory and let's look at the permissions for that folder. And from the looks of it, it is a user that has a UID of 1003. So a little trick that we can do is we can create a user that has the UID of 1003. Because if we were to try to cd into hijack, it says, hey, permission denied. Which is kind of weird, right? I mean, we can sudo cd into hijack. It's not going to do any difference because we're already root, right? So why don't we user add? We'll do test THM and then U to specify the UID, and then we'll put the UID 1003. And then we'll switch user into test THM, and we'll see, hey, who am I? Hey, we're the user test THM. So now let's print working directory. Let's cd into hijack, and let's see if it'll let us. Let's see, it lets us. So let's ls tech la, and let's see what's in that mount. So it looks like there's a text folder for employees.txt. We'll cat out for employees.txt. And we get some credentials. So let's copy this into our note-taking application. And we get the FTP user and his password. All right, so let's exit that. Let's user delete, and then we'll delete the user that we just created. Let's go back to our home Kali directory, just so we're in the home of things. And let's try to get FTP'd into that. So 10.10.72.25. Username was FTP user. And the password is pretty strong. Let's get that. Not yet. Let's enter the user, then copy paste the password. See if it lets us in. TP user. Let's clear this. FTP. Copy. TP user. I want to make sure, is that copying it? Yeah. It's copying it. We might just have to type it in, I guess. Yeah, my paste won't work. My right click will paste it though. go back. Try to right click into the FTP user. See if that did it for us. All right. We'll just type it in. FTP user. Let's just make sure. Yep, FTP user. And let's type in that password, which is capital. Login successful. All right, so it just had to make me type it in. All right, so let's dir, let's ls. Nothing's coming back, but maybe we can see if there's any hidden directories. And sure enough, there is. Let's see here. So we got a bash logout, bash rc, got a text file from the admin, and we got a password list from the admin too, I'm assuming. Let's get the from admin.text. So we're basically pulling this from that machine to our machine so we can view it. And let's get passwords list.text. So we'll probably need to use that as well. And the other two, probably just not interesting me right now. Let's go back and because they're hidden directories, they're going to have this little dot in front of them. So what we're going to do, just to make it simple, is we're going to move them into just not have the dot on them in front of them so that they're not hidden. Do that still with the admin. What was it? The password list and the from admin. And let's look at those. So cat from admin, and let's see what it says. To all employees, this is admin speaking. I came up with a safe list of passwords that you all can use on the site. Passwords don't appear on any word list I tested so far, so I encourage you to use them. Even me, I'm using one of those. All right, so we know that the user admin will be using a password that's in this password list. Note to Rick. All right. Good job on limiting login attempts. It works like a charm. This will prevent any brute forcing. Okay, we got to keep that in mind. Let's do a quick word count on this password list. And let's see how many entries there are. So there's 150 different passwords. And if we cat that out just to look at some of the passwords, yeah, they are pretty secure. So we won't be able to brute force, and it's going to take a long time, even with the rate limiting us. So we'll have to find another way in with that. So let's take some notes from that note. And we know that there is going to be a user admin. There's going to be a user Rick. And for passwords, we have the passwords list.text. So let's keep that in mind. And why don't we go and look at that website? Let me just get my virtualization software up and going here. And let me move this tab to a new window. Then we'll get full screened here. And let's get into it. All right. Just make sure OBS is pulling that up good. Yep. Awesome. All right. So let's go check out that machine. We can close these. And HTTP 10.10.10.72. $25. All right. Of course. All right. Nothing there. All right. So we get the message. Hey, welcome guests. This site is under development. Sweet. Running Apache 2.4.18. And let's actually see if that's vulnerable to anything. We can use a tool called Search Exploit. We can look up the version 2.4.18. And let's see here. So we got a Linux kernel version that's vulnerable to privileged file descriptor resource. And then we got a Sync Breeze Enterprise. So it doesn't look like this version of Apache is vulnerable. Okay, let's do just some checking on things. We'll look at the network. We'll reload the page. Maybe see if there's any back-end stuff running. Doesn't seem like it. Let's view page source. Index administrator. Log in and sign up. Under development. All right, maybe there's a robots.txt. Let's check robots.txt. No, nothing there. Home, admin, access denied. Only admin can access this page. All right. And then log in and then sign up. So let's try to log in with admin and password just to see what it says. The password you entered is not valid. All right, so hey, it's telling us that password's invalid, but hey, there's an admin user, right? Which is kind of nice to know. Because if we were to do like Billy Bob, right, and then put in a make up password for him, no account found with that username. So in the grand scheme of things, that's probably not something that we want to implement in our login fields because it could tell an attacker, hey, that's a good username that we can get into, right? So let's sign up here. Let's just create a user with the password that's something super insecure just for testing purposes. And then let's go in. We'll log in and sweet. Hey, welcome user. This site is under development. And it doesn't really give us many options besides that. We still don't have access to that administrator.php. And then from the looks of it, we can really just log out. Let's see if it gave us anything here. Go to index.php and let's see if it gave us a session. It did. So it gave us a cookie. Let's see, we can go into cookies and view it a little bit easier. Let's copy this and let's check this out under a tool called CyberChef. CyberChef is basically a Swiss Army knife for different encryptions, hashes, codes, ciphers. You'll kind of see the use case of it here. So this cookie looks like a base 64 encoded string. You can kind of tell from these equal signs right here. So what we can do is we can say, hey, CyberChef, decode this base 64 string and tell us what it tells us. So it's saying, hey, user, and then it kind of gives us a hash from the looks of it. So let's copy this and let's see, use a hash identifier. Let's identify what kind of a hash this is. I'm assuming MD5. Yep, MD5. All right, so the cookie is basically hashing the password with the MD5 hashing algorithm, and then it adds the username with a colon, and then the hashed MD5 password of that user. So because we can't brute force the password, what we can try to do is maybe brute force the session. So how we're going to do this, right, is we have a little tool. Yeah. We have a little tool here in our tools. Let's check it out here. We'll cd into Kali tools. We'll go exploitation web. And we got our session hijack.py. I was able to find this when I was doing my research for this episode, and I think it will help us out here. So basically what it's going to do is it's going to use Python to basically brute force that session for us. So we basically got to say, hey, in our home Kali passwords list.txt, which is the passwords that we want to try, we want to use the hash libmd5 because that's the type of hashing algorithm that we're using. We want to use the password admin with the colon because that's how the cookie is basically doing it, right? We basically want to create that cookie session, throw it up against the website, and then see if it accepts it. That's basically what it's doing. So let's come over here and let's change our origin to our IP address that we're trying to attack. Got 10.10.72. Oh, we got numlock again. 10.10.72.25. 72.25, and then we're going to refer to that administration page to see if it allows us access to it. And the PHP session ID is that session ID that we will be putting in as a variable to try to, brute force against it. And then let's put in the URL one more time here, 72.25. And from the looks of it, I think that might do it. Let's try it out here. Python 3 session hijack.py. And let's have it run. So basically what it's doing is it's using this password list. It's using the admin. So let's cat out password list. It's using admin, and then it's running through these different passwords. And it's base64 encoding them. Yeah, base64. I think I can do that, right? Yeah, I'll play around with it. But yeah, it's basically base64 encoding this, and then it's sending that cookie to the application, seeing if it'll authenticate. And if we look at that, hey, it says a valid session has been found with this cookie. So if we look at what this is decoded, so we can base 64 tag D, copy that, do that. What is it? The base 64 decode in Linux. 64 tag D Linux. We can also just go into CyberChef and do that. Okay, there we go. Echo. And we'll do the string. Pipe into base 64 tag D. And then we get the admin and we get the user. And then we get the password. So what we can do is go back to the website and we can use a cookie editor and we can edit our session, or we could just log in as the administrator now that we know what his password and his username is. What we're going to do, just for simplicity's sake, is we're going to copy this cookie, gonna echo that into just a simple little text file. Session.txt. All right, and then we'll come over here. We'll open up file, open, home. We need to move that. There we go. All right. Open, and there's our cookie. So we'll copy this, we'll come over here, and we will paste it, and we'll hit go. Reload the page, and then we try to view the administration page. Should be working. Let's see. Paste that again. We'll hit check. All right, I guess that doesn't want to work. Why don't we just log in as the admin then? that password again too. All right, come over here. We'll open up that file that has the password. Copy it and we'll paste it and we'll log in. Let's see here. Let's go back to that tool. We'll run it again just to make sure that we get the same output. Says that's it. Come back over here and let's grab that session. Let's try to add it to our cookie. And there we are. All right. So that allowed us to get in. We just had to play around with it, I guess. Why not? So, we have access to the administration.php, and it looks like a service status checker. Provide the service name. All right. Let's look up the service bash. Execute. Bash.service loaded, not found. Okay, well, maybe there's Python. Is there a Python service? Let's see here. What are some other services? Apache. Apache 2. Hey, Apache 2, awesome. This kind of looks pretty familiar. This is actually looking like a system CTL command. Now, I don't think I have Apache 2 running, but if I had maybe SSH, system CTL status, SSH, you kind of see this looks pretty similar here. It has loaded, as active, as docs, as process. So what I'm thinking is happening here is we have a little PHP program that's running system CTL status. We have this running, and then this is our input. So just to verify, why don't we do tac h? Because in system CTL, we can do tac h, system CTL tac h, and we should be able to see the same output. And from the looks of it, yeah, we are getting the same output. Query ascend control. Query ascend control commands to the system manager. Yeah, so we're able to potentially run commands here. And one way that we can find out is we can do... So keep in mind, right, all we're doing... Let me click through this, I guess. All right. All we're doing, right, is it's calling system CTL status or whatever the precursor is, and then it's basically running our input. So if we want it to run tac h, which we know it can, what we can do is we can pair another command onto it, like who am I, right? So all and is doing is it is doing, hey, run this and run this. And if we look, we can run this on our local machine. It'll run the systemctl help page. And in theory, it should be running our, let's maybe do like systemctl ssh, and then who am I? And then, yeah, who am I? And then it'll say, hey, this is the systemctl command, and then the who am I command runs, and it says, hey, you're root. So let's try to do that on that machine. So we'll do attack h and who am I? Scroll down, and hey, for sure, it's saying, hey, we're dub data. So yeah, we have some command injection vulnerabilities right here. So let's go back and maybe let's see if we can cat etc password. And sure enough, we can, yeah. So we for sure have command injection. So let's look here. It looks like we got the root user. Got the Rick user, which Rick has that UID of 1003. We got a FTP user with the UID of 1002. Vagrant, 1000. And usually UIDs that begin from 1000 and increase usually have a home folder. So the Vagrant user, the FTP user, and the Rick user. And then, of course, the root user, which is always the goal. So what we can do is let's look up some reverse shells here. revshells.com. And we got it going to our local IP address. Got it going to IPA, grab for ton 0. See, so that's our 10.2.19.63 is our local IP. And then the port that we want it to come back to is 1234. I believe, for simplicity's sake, why don't we just grab a, yeah, maybe this one. Let's grab that one. Oh, let's come back. And we'll do, let's see if it'll pull up SSH. Yep, okay, it'll pull up SSH. Oh, SSH, and then we'll do end our reverse shell. And let's execute. You know what, it would probably help if we had our listener going. Let's come back here. We'll do attack netcat lnvp1234. We'll set that up. Now it's listening. Let's do SSH and then our reverse shell. Let's execute it. And let's see what happens. Okay. Nothing yet. Let's go back and let's do maybe SSH and let's maybe try another one here. Maybe it doesn't like all those characters we got. I like the Python reverse shells. They usually work pretty well. We'll execute. And it says, hey, command injection detected. Please provide a service. Okay, so it has a little bit of protection in place, right? But from the apparent use, I mean, we were able to still run commands, which is not ideal. So maybe let's try to find something that doesn't have as many funky characters in there. So maybe, let's see here. Let's try like a busybox netcat. Copy that. We'll do SSH and we will send in that reverse shell. Let's execute. So that's a good sign. It's hanging, which means that something is being processed. Okay, cool. And it came in. So connect from 10.2.19.63 from 10.10.72.25, which is our target, right? Then we can type in, hey, who am I? Hey, we're dub data. And let's print the working directory. So now we have a reverse shell. We have a reverse connection to this host. So let me go to my notes here, my master notes. And let's get this reverse shell stabilized, which we've done in the past. But we'll go back through it again because it's something pretty useful. Stabilize. All right, so step 1, let's see if we got Python. So Python, tag C. Ooh, it doesn't like when we use those characters. All right. We'll have to be really careful with what we type here. ty pty dot spawn. Okay. Okay, that worked. It gave us back a user and the machine. And then, so we inflicted bin bash. Let's go to export term equal. Oh, see, we did it again there. And we can't control C because it's not stabilized. So we're just going to have to, I don't know, make it error out. Let's export it. Yep. So we can't. That's the one thing about an unstable shell is it's a pain to get working, but that's what we're in the process of right now. Export term equals x term. Enter. From the looks of it, I'm assuming it worked. I can't really tell because this unstabilized shell is. Yeah, I think it. There we go. Suspended. Suspended netcat. All right, let's go back. Let's try that again. Stabilization of shells can be sometimes a pain. Let's close this out. Let's reload the page. Let's go back, make sure that we're good. Yep, still running. SSH and we'll do our busy box to our machine and we'll execute. We'll go back. Okay. Now let's start that process again. Python. Let's start it again. Resend. SSH and busy box. Execute. Come back. No. Need to have it listening. Busy box. Execute. All right. It's hanging. All right. Let's do Python. Tag C. Import pty dot spawn. We just messed it up again. Let's make it error out here. Go through it again. Sometimes that's just part of the process. Busy box, enter. SSH and busy. Okay. Who am I? Data. Let's run Python. Tag C. Import pty dot spawn. Okay. Export term equals x term. We'll background it. We'll do stty raw dot echo fg id. And is it stabilized? It is. Nice. So now we come back. We can clear the screen. We can enter it a bunch of times. Now it's stabilized. So we won't have to worry about it breaking on us anymore, basically. All right, so let's do a little bit of enumeration. So we're the www data user on Hijack, and we're in the current directory var www html, which is the web directory. So let's go into the home directory and let's see what we can find. So there's that FTP user, and then there's that Rick user. Get permissions. Let's see if we can cd into the FTP user. See if he's got anything in there. And it looks like it's just those same FTP files that we had access to before. Clear the screen. And let's go back to Rick user. And we got the user.txt. Okay, cool. Let's see if there's anything hidden. Okay, those are going to dev null. Let's cat out user.txt. And permission denied. Probably because we're not Rick, right? So it seems like that's what we're going to have to gain access to next is the Rick user. So one thing that I always do is I'll cd into the temp directory and I'll run myself linps. So let's scroll back out here and let's go to here. Privask Linux. We'll start up a little Python web server. And we will grab linps. So wget from our host, which is 10.2. I forget every time. Let's see. 10.2.19.63. 10.2.19.63, and we are grabbing linps.sh. Alright, looks like it grabbed it, it downloaded it, and let's clear the screen, and there's linps. Now we do have to make linps executable. So what we're going to do is we're going to use chmod plus x to add the executable to linps.sh. Now, if we look, we can see that linps, before it just had read, write, read, read. Now it has read, write, execute, read, and execute. So now we should be able to run linps. And sure enough, there it goes. We get the nice little linps logo going, a little ASCII art. And it's going to sit there and it's going to run for us. Give it just a sec, let it do its thing here. It's running through. Let's look here. So there's that port. There's the ports that we had seen open. And it looks like it's running MySQL locally. So that's kind of cool. Maybe we can check that out, see if it's maybe has any admin, password hashes or anything like that. We can check that out. Come on, linps. Clear that. Okay, from the looks of it, it looks like it got all cleared up. Let's see what we can find. And already, right off the bat, what do we find here? Searching passwords and config PHP files. We see a environment variable set within that PHP file for password. And the password is this. So, never gonna give you up. Like the Rick Astley song, right? Never gonna give you up, and then we have a user Rick. So maybe let's see if those two align. So let's try to clear this, and let's do switch user Rick. And let's provide his password. Never gonna give you up. And sure enough, hey, would you look at that? We are now the user Rick. So the user Rick left his password inside of a PHP config file. All right, cool. So let's go back to home and Rick. And we now can cat out user.text, right? And there we are. There's our flag for the user. Awesome. All right, well, now all we have is the root user. So let's do sudo tac l, and let's see what we can run as root for the Rick user. It'll let me paste again. Let's see. There we go. All right. So the user may run the following commands on Hijack. So it looks like we can run user sbin apache2, apache2.conf, apache2, ld library path. Okay. Now, when I was initially working through this room, which I do this before every live stream event, is I go through a room just so that I can limit the time that the stream is and everything. I was kind of lost on this, and I thought, how would I use Apache 2 to escalate my privileges to root? Because I knew that this was the path, right? And doing a little bit of research, I noticed that this LD library path variable basically tells Apache where to grab its dependencies from. So what I had basically found was that if we were to basically type in a command like this, ldd user sbin apache 2, we can basically find all the different dependencies that Apache needs in order to run, right? So if we look, there is libcrypt, there's libc, libthread, libapr, libcree, linux, all these dependencies. And dependencies, they could be another name, but that's just what I want to call them. All right, so basically what we could do is we could take one of these dependencies, funge it, basically make our own, and then point Apache to it, or point that environment variable to it. So what we're basically going to do is create a small C program, right? And we're going to call it the same name as that file. So for instance, we can name it, let's see here, libcrypt.so.1. Well, no, let's actually just make sure that we grab it. libcrypt.so.1. All right. So let's nano that. And then what we're going to do is basically create that. So it's include library stio.sh, include stdlib.h, include st.h, honest.d.hk, and then static void hijack attribute structure void hijack unset env ld library path, set ruid to 0, 0. And then system, what we're going to basically have system do is run bin bash tac p, which will basically launch a session within that current environment, or within that current system shell. And believe that is everything that we have to add. Just make sure that don't have any typos here. Set. All right. So from the looks of it, that looks good. Now what we're going to do is we're going to compile it because it's a C language, right? It's not interpreted like Python. We got to compile it and then we're able to run it. Let's move libcrypt into temp. Let's cd into temp. There's our libcrypt. And we'll use GCC to compile it. We'll point it to temp, libcrypt, shared, tag fpic, home, rick. Oh. Let's actually move that back to where it was. All right, GCC, tag O, temp, libcrypt.so. You know what? Let's go back. We actually need to name this .c so it knows that it's a C language file. So let's move libcrypt into very path.c instead. There we go. And we'll do GCC tag O temp libcrypt.so.1 shared fpic home rick library path. All right. We'll let that compile here. Looks like it was good. And now let's run what we need to run as root. So we'll do sudo ld library path equals temp user sbin apache 2 etc apache 2 all right, it's kind of a long string here. Why don't we just copy it and paste it? Okay, let's copy. We'll run it. And would you look at that? Hey, we're root, right? So basically what we did was we found that as root, we could run that Apache 2 kind of command, right? And then we noticed that that environment variable library path, we could basically point it to our own dependency, right? So we created a funged up dependency that actually would just spawn a system reverse shell. And then we basically ran Apache with that new funged environment variable set, and we were able to pull root. So from that point on, we now own this machine. So we can change to the root directory, and sure enough, hey, there's our root.txt. So that is how we take over Hijack, right? So to go back through, basically what we did was we scanned the host. We found that port 21 was open, FTP, NFS, and HTTP were open. Those were the ones that got us into root. Using the NFS share, we were able to funge a user to gain access to that share using the UID 1003. Once we were able to gain access to that, we found a note that contained FTP credentials. Once we got into FTP, we found a note that had a password.txt document, which contained a bunch of potential passwords, and then another document that had told us about some users and then some other key information. Using a session brute force technique, we were able to get the admin cookie. Once we were able to gain the admin's cookie, we were able to get in and noticed that we had a command injection vulnerability within the admin.php script on the web server. Using that command injection vulnerability, we were able to gain a reverse shell. After stabilization of the reverse shell, we were able to gain access to the RIC user via a config.php file that was scanned by linps. Once we had access to the RIC user, we found that the RIC user could run Apache 2 as root on that machine using sudo. And via some library dependencies and some misconfigurations, we were able to funge a Apache 2 dependency. And with this Apache 2 funge dependency, we were able to basically make it pull from a command that we could make it run. And that allowed us to run bin bash tacp, which would basically allow us to spawn a root shell after we would run our sudo command. So that's how we got root on Hijack. I'd like to thank everyone for coming out, and either whether you're live or whether you're checking the YouTube video. But I think that'll do it for me. You guys have a great rest of your night, and thanks for watching. I hope you guys got some value from it. All right. See you guys.